Hello all, welcome back. As we see in our previous video, the Pearson's correlation R or the Pearson correlation coefficient tell us about the strength of linear relationship between two variables. However, to decide whether the relationship in the sample is strong enough to use to model the relationship in population, we have to perform hypothesis test of significance of the correlation coefficient. So we use the hypothesis to interpret or draw the conclusion about the population using the sample data, and it evaluates two mutually exclusive statements or claim about the population to determine which statement is best supported by the sample data. So before we start with in detail about hypothesis testing, let us discuss about the terminologies that we should be aware of in hypothesis testing. So let's begin with the population and sample. Like, the population is a collection of objects, and it's the collection of objects that we want to study or test. The collection of objects could be cities, students, and factories, and so on. And basically, the population depends on the study of our interest, like uh, what kind of population, or what is the population of our interest. And similarly, sample is nothing but the subset of the population. And another terminology is the parameter and statistic. A parameter is a value that describes the characteristic of the entire population. Like, the population mean and standard deviation are two common parameters. And in terms of sample, we call the sample statistic. And a static is a summary or the description or the summary description of characteristics or a measure of sample. And the common sample statistic in use, uh, like the sample statistic used as an estimate of the population parameter, and the common sample statistic are like sample mean, sample variance, sample standard deviation, and so on. And we're talking about the sampling distribution. The sampling distribution is the probability distribution of the statistic obtained through a large number of samples drawn from a specific population, or we can define it as like sampling distribution. It refers to the probability distribution of statistic that comes from choosing random samples of a given population. And for example, suppose if we want to perform a study to determine the number of kilometers the average person in Korea drives a car in one day, it's not possible to measure the number of kilometers driven by every person in a population. So what I do is, we randomly choose a sample of 10 people in the from the population, and then record how far they have driven. And then we randomly sample another 10 drivers in Korea and record the same information. And we do this, for example, we do this for a total of 5 times. And here we can see here in the table, like it can be taken as a distribution. Like, there are we have the sample index, like we have total 5 samples, and here is the average number of kilometers. And what we can see here is, each sample has its own mean value, and each mean value is different. And we can continue this experiment by selecting and measuring more samples and observe the pattern of the sample means. And
Could you try again?
and we continue this experiment by um, selecting and measuring more samples and observe the pattern of the sample means. And this pattern of the sample means represents the sampling distribution of the number of kilometers a person, the average person in Korea, drives. And suppose in this example, if we increase the sample size, like we see what happens to the sampling distribution if we increase the sample size. Like here, in our previous example, the sample size is equal to 10 and the number of samples was 5. And as the sample size n gets larger and the sample means tend to follow the normal probability distribution, and the sample mean tends to cluster around the true population mean, and it holds true regardless of the distribution of the population from which sample was drawn. Like it doesn't matter what was the distribution of the population, uh, the like the it doesn't matter what was the population. The if we increase the number of if we increase the sample size n, the sample mean tend to follow the normal probability distribution. Like you can see here, this is the population distribution, and here is the sample of size n. And like if we increase this n, then the sampling distribution tend to be like this. Here what happens is, like we can see that the distribution of this sample mean follows a normal distribution or Gaussian distribution, and it happens when we increase the number of sites, or the number of sample sites. And uh, this is what the central limit theorem states. As the sample size increases, the distribution sample mean approximates a bell-shaped curve, that is the normal distribution curve, regardless of the population distribution is normal or not. So the central limit theorem helps in constructing the sampling distribution of the mean, and the theorem is the idea of how the shape of sampling distribution will be normalized as the sample size is increased. So the more sample grows the more sample groups um, that we use, the less variable the mean will be for the sample groups. And when the sample size increases, the standard error also decreases. Therefore the center of the sampling distribution is fairly close to the actual mean of the population. So what this means is, like we can see here, that the center of the sample mean comes close to the original population mean. And here we can also uh, like we can estimate the standard error of the mean in the standard deviation. Like we can also estimate the standard error. This standard error is nothing but it is the standard error of the mean is nothing but it is the standard deviation of the sample means. And the standard error is very similar to the standard deviation, and both are the measures of spread. And we can estimate the standard error by using this formula. This is the standard error, or the standard deviation of the sample means, and it is obtained from the sample mean divided by the root n. This n is the sample size. So these are the basics of the terminologies that we use, and the brief introduction of the central limit theorem, and some kind of relationship between the sample parameter, sample statistic, and the population parameter.